Okay, now let's understand the intuition of an insertion sort algorithm. So understanding intuition is much more important because once you truly understand how insertion sort works, writing the code becomes a straightforward one. And it's just an extension of that idea what we have. So that's why the intuition of an insertion sort algorithm is a very important for us. So for that, let's take a simple example, right? Let's say I have an array, right? So array A is equal to 6, 5, 3, 1, 8, 7, 2, 4. So total we have 8 number of elements are present in an array. So this is my unsorted array. So this is an unsorted array, right? Now let's say I have a task. So the task here is I want to sort this array in an ascending order. So I need to sort them in an ascending order. By default, whenever we say sort, we mean sorting in an ascending order unless stated otherwise, right? If we specifically want a decreasing order, we will mention it explicitly. Otherwise, ascending order is assumed. If somebody says that sort an array, default assumption should be an ascending order. The default order should be an ascending order. Now let's go step by step. Let's understand how the intuition of an insertion sort algorithm works. Right? Now I'm going to start with the first element. So what is the first element present in an array? This is my first element 6. Right? And assume that there is only one element present in an array and that element is 6. So what we have to do? So my task is to sort an elements in an ascending order. So we cannot do anything about a single element, right? Because a single element by itself it's a sorted. So the array of size 1 is always sorted. So we assume the first element forms a sorted subarray. So what is meant by subarray here? Subarray means it's a portion of an array. So as of now, I just processed only one element in an array. What is that element? That element is 6. Now we'll move on to the next element. So I'm going to pick the second element in an array. What is the second element? The second element here is 5. Right? So in this case, as part of this algorithm, what I'm going to do now is I'm going to keep that element into the variable called key. Now my value of key is equal to 5 here. So the value of key is equal to 5. Now I'm going to compare 5 with the sorted subarray. So as of now, I just processed only one element, right? Now I'm going to compare 5 with the elements in the sorted subarray. So only one element I have. Now I'm going to ask, is the element 5 is smaller than 6 or greater than 6? If 5 is smaller than 6, in the final sorted array, 5 must come before 6. That means 5 should be placed left side of a 6. Now in this case, what I will do, I will shift this element 6 one position to the right side. So that means I'm going to keep 6 here. So guys, again, I just kept the blank place, but here the actual array is there. So actually in this place earlier it was 5 is there, and I'm just replacing 5 with an element 6. And now is there any other element to compare with the value k here? No, right? Now what I will do now is I'm gonna keep that element 5 into this particular position. So after this step, the array becomes 5, 6, 3, 1, 8, 7, 2 and 4. Now the first two elements, so these two elements are sorted. At this point, something very important has happened. What is the important thing happened here? The array is divided into two parts, right? So this is my processed subarray and this is my unprocessed subarray. This is my unsorted, unprocessed subarray. And this subarray is sorted and this subarray is unsorted. right? Still I did not process at. When I say sub array means I simply mean a portion of an array, right? So the left portion is always sorted and the right portion is yet to be processed. So after the first iteration, first two elements are sorted. The rest of the array remains untouched, right? So at the end of the first iteration, let me write it down here. At the end of the first iteration, first two elements are sorted. Now what I will do, I will move to the third element. Now again I will repeat the same steps. So I'm just keeping that element 3 into the variable k here. Again I'm gonna compare the element k with the processed subarray, that means sorted array. Now I'm gonna compare k with an element 6 first. So which element is smaller? 3 is the smaller. That means this element should come left side of the element 6. So in this case, I'm gonna move this element 6 to the right, one position to the right. Now again, I'm just comparing k with an element 5 here. 5 is greater than 3. That means 3 should come, or 3 should be placed left side of an element 5. That means I'm just moving 5 one position to the right here. So instead of that, let me change the color so that it will help you to understand much better. So I'm just changing the color here, guys. So the color here is 6, 5, right? Now is there any other element to be compared with an element k here? No, right? To the variable k, no, there are no other elements to compare. Now I'm just keeping that element 3 at this position, right? And remaining all other elements are remain same. So 1, 8, 7, 2 and 4, right? So at the end of the second iteration, these 3 elements are in the sorted order. So again, if you look at any point of time, you will be going to have the two subarrays. One, this is the processed subarray and this is my unprocessed subarray. Now we'll move to the fourth element. Okay, now again I'm just repeating the same process. K is equal to 1. Okay, I will keep that element 1 into the variable k here. So the portion to the right, 8, 7, 2, 4 will remain untouched. We will not modify that part yet. We will work only within the sorted portion on the left side. Only this portion I'm going to focus on it. So at this stage, the left portion before inserting 1 is what? 3, 5 and 6. Now, first step here is I'm compare with a 6. Since 6 is greater than 1, 6 must be shifted one position to the right. So I'm just keeping 6 here, right? Now again I'm comparing the element k, the value of k with an element 5. Now compare k with 5. 5 is greater than 1. Shift 5 to the right. Shift 5 to the right, right? Now what I will do now, I'm gonna compare with 3. Compare k with the 3. 3 is greater than 1. Shift 3 to the right. Shift 3 to the right. So is there any other element to be compared? There are no more elements to compare with. We have reached the beginning of an array. So we place the value of key in the first position. So 1 will be placed here. So after this step, the array becomes 1, 3, 5, 6 and 8, 7, 2, 4. So this is the unprocessed subarray and this is my processed subarray. So what is the next element? The next element here is 8. Now again I'm just repeating the same steps. The value of k is equal to 8. I'm comparing 6 with an element 8, right? And 6 is less than 8, right? There is no need to change or this position, this element should be keep it at the as it is exact place. So next, there is no need to move the element to the right here, right? So I'm just keeping the elements as it is because it's already in sorted order. Then no need to compare with the remaining all other elements in an array. And at the end of the fourth iteration, what is my array? Array contains the elements are 1, 3, 5, 6, 8, 7 to 4 at the end of the fourth iteration. Now, in the next step, again I'm gonna pick the next element here. The value of k is equal to 7. Now I'm going to compare 7 with an element 8. Right? Since 8 is greater than 7, right? 8 must be shifted one position to the right. So 8 will come here, right? And I'm gonna compare 7 with an element 6. 6 is less than 7, then no need to change anything. No need to move this element to the right position since they already in the sorted order. So at this particular point of time, I will place 7 in this particular position. And remaining all other elements are at the same place. So at the end of the fifth iteration, my array contains the elements are 1, 3, 5, 6, 7, 8 and 2, 4. Now, then in the next step, I'm gonna pick the next element is 2. Now my value of k is equal to 2. I'm going to compare 2 with an element 8. 8 is greater than 2. That means we must be shifted one position. The 8 must be shifted one position to the right. Right? So 8 will come here. Then I'm gonna compare 7 with an element 2. 7 is greater than 2. That means 7 must be shifted one position to the right. 7 will come here. Okay, now I will compare 6 with 2. 6 is greater than 2. 6 must be shifted one position to the right. So 6 will be here. Now compare 5 with 2. 5 is greater than 2. That means 5 must be shifted one position to the right. So 5 will be here. Now 3 is greater than 2. 3 must be shifted one position to the right. So 3 will come here. Now what about 1? 1 is greater than 2? No. That means, so these two are already in the sorted order. Now in this particular place, I'm gonna place 2 here and 1 will be at the same place. Now at the end of the sixth iteration, my array contains the elements are 1, 2, 3, 4, 5, 6, 7, 8 and 4 is at the last place. Now at the final step, right now I'm at the seventh iteration, right? So I'm going to process the last element of an array. Now my value of k is equal to 4. Now again I'm gonna repeat the same steps. Compare 4 with an element 8. 8 is greater than 4. That means, so 8 must be shifted one position to the right. So 8 will come here. Right? 7 is greater than 4. Yes, 7 must be shifted one position to the right. 6 is greater than 4. 6 must be shifted one position to the right. That means I'm gonna place 6 here. 5 is greater than 4. Yes, 5 must be shifted one position to the right. Is 3 is greater than 4? No. I will stop it right away, and at this particular position I'm just placing the value of k here. So the value of k is equal to 4. And remaining all other elements are untouched because they are already in the sorted order. Compared to 4, these 3 elements are smaller. Right? Now at the end of the last iteration or the end of the seventh iteration, all elements are in the sorted order. Right? So this is how the insertion sort works. At any particular point of time, right? So at any particular value of k, right, there will be a 2 subarrays. One will be a processed subarray, one is unprocessed subarray, right? So let's say right now I am here. So this is my processed subarray, and this subarray is already in a sorted order, and this subarray is unsorted. So these elements has to be processed at, is not processed yet. So this is how the insertion sort algorithm works. So this is the one of the beautiful sorting algorithm you must learn. And also I want to show you one interesting animation from the Wikipedia page. So whenever you have any doubt, so you can find each and everything in a Wikipedia. This is one of the best blog, the best content you can ever find in a Google, that is on Wikipedia. So right now I'm at the Wikipedia page, right? So the name of that algorithm is an insertion sort. So what I want to show you here is this a simple animation. So again, let me refresh the page. So if you look at initially, I have unsorted array. So right now I just took the same example here while explaining the intuition of an insertion sort algorithm. Now if you look at, so right now I'm at this third element. I'm comparing 3 with element 6. 6 is greater than 3. I just moved 6 and 5 to the right position, and I kept the element 3 at the first place. Then I have 1. 6 is greater than 1. I just moved all of these 3 elements to the right position, and I just kept the element 1 at the correct position. Now I'm trying to check with an element 7. So my value of k is equal to 7 now, and 8 is greater than 7. I just moved the element 8 to the 1 position to the right. Then 2, I'm comparing all other elements. So wherever this element should be placed in the proper, now I'm gonna compare all other elements and remaining elements to be moved to the right position. So this is one of the best beautiful animation you can find ever in a Wikipedia page, right?